Let's start with question 1. Uh, Read question 1.
The battery in an electric car needs to be recharged. Suggest two factors that affect the distance of an electric car can travel before the battery needs to be charged. That would be the weight and the
Yeah,
speed the car is going.
exactly. Speed and mass. Yeah, that's correct. Good.
Write down the equation with links: acceleration, change of velocity, and time taken. So,
Yeah,
1 second. Acceleration equals change in velocity divided by time taken.
exactly. Acceleration is equals to change in velocity divided by time. Okay.
Maximum acceleration of the car is 20 meters per second. Calculate time taken of the car to change from 0 to 28 meters a second as
Yeah.
at its maximum acceleration. So you need the time.
Hmm.
So time equals a change of velocity divided by acceleration.
Yes.
So change of velocity is 28
Yes. 28 minus 0, 28.
divided by do I need to root 20?
Yeah, 20. They both have same units, so just write 20.
So 28 divided by 20 equals 1.4 seconds.
Very good. Yeah. So the answer is 1.4 seconds. Okay. Next question.
In a trial run, the car accelerates at 10 meters per second squared until it reaches its final velocity. Distance traveled by the car is 605 meters. Initial velocity of the car is 0 meters. Calculate final velocity using physics equation sheet.
Yeah.
So you want distance and velocity. Initial velocity. Okay, fine. So,
Yeah.
um,
Final velocity, initial velocity, acceleration, and this is distance. In which equation we have all of these?
acceleration, final velocity, and distance. 1 second.
Okay.
Um, I have acceleration equals change in velocity divided by time taken. But
No. We have, but that does not have two velocities. Okay, that has, but that doesn't contain distance.
uh, hmm, there's none. There's none on my sheet that say acceleration. Other than that,
Okay. Can you get this final velocity square minus initial velocity square is equals to 2 times acceleration times displacement or distance? Do you
oh,
have
I
this?
found it. I found it.
Yeah.
Yep.
Okay, let's what we need final velocity. This v is final, u is initial. So let's rearrange them and find the final velocity.
So final velocity Final velocity equals. Hmm, I don't know how to rearrange this one.
Okay. So see, we have to find this. This is final velocity, v square, and initial is u square. So v square is equals to 2as. This is minus u. So when we move it to other side of equal sign, this will become
Wait, final velocity equals what?
this is final velocity, this is initial velocity, this is acceleration, and this is distance. Okay. So because we
Yes.
need this v square, so we need to move this term other side, here, other side of equal sign, right?
Yeah.
So this is negative. When we move a term to other side of equal sign, it the sign flip. This is negative. This will become positive u square. Okay. Now we
Yeah.
need to get rid of this v square. So we square root, and this is what we have. Okay. So final velocity is square root of 2 times acceleration. What is acceleration here?
Uh, so 2 times acceleration is 10, so
10.
20.
Yes. And distance, s is distance. What is distance here?
And then distance is 605 meters.
Yes. Plus initial velocity. What is initial velocity?
0.
0. So just we need to solve this. 20 times 605.
12,100.
Yes. And if we square root this, what we will get?
And then 1 second.
Okay.
110.
Yes. So velocity is 110 meters per second. This is the final velocity. Okay.
Yeah.
Yeah.
Okay.
So let's see next question. 1.5.
Distance. Write down an equation with links distance, force, and work done.
Hmm.
Uh, distance, force, work done. Distance. Um, Work done equals force times distance.
Yes, very good. That's correct. Next.
When traveling at maximum speed, the air resistance of acting on the car is 4,000 newtons. Calculate the work done against the air resistance when the car travels a distance of 7.5 kilometers at its maximum speed. So the
Hmm.
force is 4,000.
Yeah. Force is
So you
4,000.
do 4,000 and then you times it by. Do I have to change 7.5 kilometers into
Yeah. Meters.
kilometers to meters? 7,500 meters.
Yes, exactly. 7,500 meters.
So 4,000 times 7,500
Yeah.
equals 30 million.
Yes. Which is 30 megajoules.
Yeah. Megajoules.
Yeah. When you have, because mega means 10 raised to power 6 joules. It has, hmm.
Isn't it joules?
Yeah,
Because on
joules.
the work. So 30 million joules.
Okay, okay. So here it is given joules. So yeah, you can write 30 million joules.
Okay.
Okay.
A student used a ray box to shine a ray of light through the air into a glass block.
Hmm.
Student investigated how the angle of refraction varied with the angle of incidence. Describe a method the student could have used to obtain the results in Table 1. You may your answer may include a label diagram.
Yeah.
That's
So,
you get paper, you get a glass block, and you draw an outline of the glass block. Then
mm-hmm.
you get a light ray box, and you
Yeah.
put the cover on, so only one light passes through, and the light passes through the glass block, and you have to take notes down where it passes through.
Yes, exactly. First, we place a rectangular glass block on a plain sheet of paper, and then we trace around the block using a sharp pencil. And when we remove the block from the paper, we draw a 90-degree normal line, which is called normal. And then we use protector to make the normal, and we uh, replace the glass block, and then we turn on the ray box, and because it shine a narrow ray of light at the point, that angle will be incident ray. Let me draw here diagram. This is your block. Okay, this is your
Yep.
normal. Normal means 90-degree to the surface, which makes 90-degree angle. And this is, let me change the color, this ray which is incident on the surface of block, this is called incident ray. Here we can write incident ray, and this angle is, we can denote it with letter I. This is called incidence angle. And then we have this ray. This is called refracted ray or refracted beam, and this is angle of refraction. Okay, so this is showing refraction of light. An angle of incidence is equal to angle of refraction. This
Yeah.
is, we can name this point. So basically, this is incident ray. It should pass straight, but why it is bending towards the normal, we have to also represent it with arrow, because the medium is changing. Because here this is air, right, and this is glass. So what is happening, as the medium is changing from air to glass, and then again from glass to air, the light, instead of passing straight in a straight line, it is bending. It is bending towards normal, and because of the refractive index, it will sometimes it bend towards normal and sometimes away from normal, which depends on its refractive index. So yeah, you can measure angle of incidence. This is angle of incidence, this is angle of refraction, by using this experiment. So first you need to set up all the equipment like this, then you will direct the light ray, then you will mark and measure the path, and then you will collect all this data. You will measure the angle of refraction using protector. Okay,
Yep.
and you have to repeat the steps for all angles up to 80 degrees, as you can see here. Did you write what you have to do, or should I make you write?
All right.
Okay, you have to draw this also. Did you draw it?
Um. Yep.
Okay, good. So figure 2 is an incomplete graph. We have to label axis and plot the remaining data. Okay, so let's
I
see.
didn't. I
Wo-
already did.
Oh, you did this? Okay.
Yeah.
What did you write on both axes?
Angle of reflection on the left side and angle of incidence on the bottom.
Yeah, angle of incidence on x-axis here, and on y-axis angle of refraction, right?
Yeah.
Okay. Did you draw the line of best fit?
No.
Okay. Line of best fit means did you connect the points?
No.
Okay. Connect the point by a line. Okay,
Yeah.
suppose your points are going this, like this. So ignore this point and join these points. This is called line of best fit. The line, you have to connect points and make it a straight line. If one point is going here and there, ignore it and just draw a line joining these. Okay.
Yeah.
Okay, this is called line of best fit.
Mm,
Okay, then we have 2.3. Okay, draw a normal line, draw a reflected line, ray. Normal means it makes 90-degree angle with the surface. That is called normal. And reflected is the line which bounce back after, like the ray which will bounce back. So
Yeah.
this is normal. Let me use the normal is this. Suppose this is making 90-degree and this is going to be reflected. Remember, this is not refracted. In other case it was refracted. Let me show you what is the difference. See, this is normal. You have to label it. Okay, this is normal, and putting arrow is very important. You have to make sure you draw arrow. This is going in this direction. This one is reflected ray.
Yeah.
Reflected ray. And if they ask you to draw an angle of incidence, this is angle of incidence and this is angle of reflection. Also, this reflected means when it just bounce back into the same medium. Like here, this is medium is air, incident ray come, it strike this surface and come go back, bounce back. This is called reflected ray. But if medium changes, that is called refracted. There is R, that is called refraction, and this is reflection. There we have L. Remember, the last diagram was like this is a glass slab and this is incident ray and this is normal and this is refracted ray, because the medium has changed from air to glass. So this process
Yeah.
is called refraction, but here medium remains same, that's why it is called reflection. So when it says reflection, it bounces back into the same medium, but here it is entering from air to glass to air again. Okay, so
Yeah.
did you draw it?
Mhm.
Okay, you have to label. Make sure you label name after drawing. Mm. Okay, let's read 2.4.
Two students investigate the reflection of light by a plane mirror. Figure 4 shows the different equipment the student used. Method A, Method B. Explain two ways that Method A is better than Method B. I said Method A uses a better laser, which is thinner and more accurate, so less measurement errors are made for one of the
Okay.
reasons. And then for Method A, I said Method A also uses a protractor, unlike Method B, which is just on the side, which isn't being used.
Yeah, method A does not diverge like method B. And It do not have the it do not have to move mirror to measure the angles, right?
Yeah.
Which is that's why method A is making it easier to judge the center position of the ray than B.
Mm-hmm.
Um, okay, yeah. So because of the laser, main reason is this, right? Oh, sorry. Did you write this?
Yeah. Speed limits on roads increase safety. The braking distance of a car increases as the speed of the car increases. Give two other factors that increase the braking distance of the car: the tire tread
Hmm.
and the surface of the road.
Yeah. Surface of the road, if like poor conditions of tires, you have to write like that, or poor conditions of, or if the road is wet or icy, right?
Yep.
Hmm.
Explain why the driver's reaction time affects the thinking distance of the car. If the driver takes longer
Hmm.
to react, that means the car, that means it will take him longer to press the brakes.
Yeah, because the
And
formula is distance is equals to speed times time. If we increase time, the distance will be longer, right?
Mhm. So the longer it takes him to press the brakes, the longer it
Distance.
takes him to stop,
Yeah.
and the more distance he covers.
Yes.
Um, Scientists have investigated how drinking alcohol affects a person's reaction time. Figure 5 shows the results of the investigation. Which of the following conclusions can be made about Figure 5? Um, Before drinking alcohol.
Hmm.
Um, 1 second. Reaction time for every person's reaction time. Mean reaction. Mean reaction time increases after drinking alcohol. Is
Exactly.
one.
Yeah. You can see a mean reaction after drinking. Here it is around 0 0.5, and here it is around zero point 0.9, right?
Yep.
Hmm.
Some people's reaction time is not affected by drinking alcohol,
No.
or is it the change in reaction time is not the same for all people?
Yes. The change, it is not same for all the people. Yeah. That one is correct. Okay. Because it is changing for everybody, but there is a range of values, right?
Figure 6 shows some speed cameras on a road. The speed cameras determine the average speed of cars on the road. Speed limit on the road is in Figure 6 is 20 meters per second. Camera is in Figure 6 are 1.5 kilometers apart. Calculate minimum time it takes to travel 1.5 kilometers without breaking the speed limit. So you need speed, distance, speed
Yeah.
and distance. Distance travel equals speed times time.
Yes. What you have to find here is time. So what is time?
1 sec. Time equals distance traveled divided by speed.
Yes, absolutely correct.
So the speed equals 20 meters per second.
Yes, speed is 20. Yeah. Check unit of distance.
Is The unit, should I change kilometers into meters, or
Yes.
then the 1.5 kilometers equals 1,500 meters.
Yes.
So then 1,500 divided by 20
Yes, exactly.
equals 75.
Very
So the
good. Yeah.
minimum time it takes is 75 seconds.
Absolutely correct. 75 seconds. That's great.
The average speed of a car between the cameras and the average velocity of the car between the cameras is different. Um, explain why.
Hmm.
Velocity equals. Velocity.
Why? Because velocity is a scalar quantity. Scalar means it only depends on distance. It does not have, I mean, speed is a scalar quantity. Scalar means it has just values, no direction. Vector means it has values as well as direction. Velocity is vector. You can remember V. It start with V. Vector also start with V. They both start with V. Vector velocity. Speed is scalar. Okay, it does not include direction. So also the road is curved and it changes direction between two cameras. Because of the curve, the actual distance traveled along the road is greater, right, than the displacement. Because displacement means what? Displacement is the shortest distance. Okay,
Yeah.
when we talk about displacement, we talked about initial and final point. This is displacement between these 2 points, but distance can be all these. Suppose one person take this path, other take this path, so all these are distance, but this shortest is displacement. And velocity include displacement, so velocity is smaller than speed because speed includes distance.
Yeah.
Did you write it?
Yeah.
Good.
Hailstones are small balls of ice. Hailstones forming clouds and fall to the ground. A hailstone falls from a cloud and accelerates. Why does the hailstone accelerate? Accelerates because of gravitation. When it drops from above, it speeds up as it continues falling because of its weight. Oh,
Yes, because the weight is greater than air resistance, right?
yeah.
Yeah. So because of
And then
weight, it apply force downward.
the hailstone stops accelerating and reaches terminal velocity. Explain why the hailstone reaches terminal velocity. Is
Hmm.
that when it just stops speeding? It's like a
Yeah.
constant speed. Oh, it's because the air resistance and the weight have equaled out.
Yes, because as they falls, as the air resistance acting upward, it start increasing because of increasing air resistance, and eventually, like you said, they will become equal. So because there is zero resultant force, the net force is zero. That like the weight, gravity and air resistance, as they become zero, it stop acceleration, and which cause it to fall at the constant terminal velocity.
Yeah.
Hmm.
Scientists investigate how the massive hailstones affects their terminal velocity. Figure 8 shows the results. Why does terminal velocity increase with mass? Uh, as mass increases, the cross-section surface of the house, as mass increases, the volume of the house increases.
No.
As mass increases, the weight. As mass increases, the weight of the hailstone increases.
Yeah, this option is correct. You can see here in graph.
Explain the difference in the maximum kinetic energy of a hailstone with a mass of 10 grams and a hailstone with a mass of 20 grams. So, do I need to use a thing sheet?
This difference of,
Kinetic energy.
yeah, kinetic energy.
Kinetic energy equals 0.5 times mass times speed. So, if the mass is higher,
Hmm.
the kinetic energy is also higher
Yeah.
because 0.5 times mass times speed equals kinetic energy. So if mass increases, the higher the kinetic energy
Yes,
made.
if exactly. Greater mass means greater velocity, greater kinetic energy. Yeah.
Kinetic energy of a hailstone is measured in joules. Which of the following is the same as 1 joule? Uh, Newton meter.
Yeah. Can you explain how you got Newton meter?
Is it the one without the dash? Or is it the one with the dash?
Without dash, because the formula for energy is this also, or for work done, force times distance. Force unit is Newton and distance is meter, so Newton meter. This first option is correct.
Okay.
Yeah.
Um, Figure 8 repeated below. A hailstone hits the ground at its terminal velocity of 25 meters per second. Hailstone took 0.060 seconds to stop moving. Determine the average force on the hailstone as it hits the ground. Use information from figure 8. So, hailstone hits the ground at a velocity of 25. So, at 25 velocity, and it hits the line and it goes down and it's at 1, 2, 3, 5, 6, 7. Is it 18 mass in grams?
Mass in grams. Uh, this is, yeah, 18. Yeah, 18.
Okay, then use physics equation sheet so you have the mass, the velocity, and time. So mass, time, and you want force.
Yeah.
Force, force. Moment over force equals force times this. No. Force. Time and force. Um. Resultant force equals mass times acceleration.
Yeah. So you can write acceleration as change in velocity over time, right? If you use this
Uh,
formula, mass times acceleration, acceleration is this, isn't it?
so
This is acceleration. Change in velocity over time.
I need two equations.
Yeah.
So acceleration equals change in velocity divided by time.
Hmm.
So change in velocity is 25.
It is because Final velocity is 0, right?
Yeah, so minus 25.
Yes, minus 25. Good.
Minus 25 divided by 0.060.
Yes, minus 25 divided by 0.060. This will give you acceleration.
That is 400 minus 416.
Minus 416. Okay.
16.66. 0.66. And then use acceleration. So force e but once the average force. Resultant force equals mass times acceleration.
Yeah.
Mass is 18.
This is given masses in grams. So we have to convert it into kilograms. Okay.
So 18 grams to kilograms is 0. There's 1,000 grams in kilograms, right?
Yeah. So you divide
So
by
zero
1000.
point 0. So 18 divided by 1,000. 0.018.
Yes, 0.018 times it with.
0.018. So 0.018 times minus 416.66.
Very good. Which is equals to.
18 times minus 416.66 minus 7.49.
Yeah, minus 7.49.
49
Okay, yeah. Does it
or
say to
50.
round it? Or you can just write 7.5 if it says to round it or give
It
some.
doesn't say pound.
Okay, so then you can write 7.49 negative. Negative means it is acting in the opposite direction of its motion.
Is that the answer?
Yeah, that is the answer because it is asking force, right?
So, what is meant by the center of mass where all mass is concentrated in the middle?
Yes, the point from which weight may be considered to act, or the point where all the mass appear to be concentrated. Yeah.
Okay. Calculate mean weight of a tomato in figure 9 using physics equation sheet and gravitational field strength. So, gravitational field strength, gravitational field strength, gravitational potential energy equals mass times gravitational field strength times height. But you don't do it? No.
Yes, mass times gravity. Yeah.
That's what I use.
That's, yeah, weight is equals to m times g.
How do I get the height though? There's no height.
No, no, not gravitational potential energy, only weight. The formula for weight is also m times g. This is the weight.
Mass. So do I need to know that was on the thing?
I
Oh
think
wait,
it should be. It should. Can you check it is on the equation sheet?
because it says to use the equation sheet, but oh
Yeah.
yeah, I see it. Weight equals
Yeah.
mass times gravitational field strength.
Yes, exactly.
So 9.8. The mean weight of a tomato.
Yeah. What is the mean weight?
So there's 1, 2, 3, 4, 5 tomatoes on there,
Yeah.
and the weight is 400 and I think that's 425.
425?
Yeah, 425 grams. So you do 425 divided by 5.
Yeah, 425 divided by 5,
is
we get
85
mean.
grams. 85 grams is one tomato. So
Convert
do
it
I
into
keep
kilograms.
then 85 grams to kilograms is uh 0.85.
0.085, right?
0.085.
Hmm.
So 0.085 times 9.8
Yes,
equals 0.833.
yes, absolutely correct. 0.833.
Figure the balance in figure 9 contains a spring that compresses when the tomatoes are placed on the balance. Figure 10 shows a spring with no force acting and with 6 newtons force acting. Determine the spring constant of the spring.
Hmm.
So spring constant, 1 second, spring constant. Elastic potential energy equals mass times, no,
No, there
elastic
is no
potential
energy.
energy,
There is no energy.
no, but the spring constant.
Yeah, and there is a force, right? Check force and spring constant
Um,
and extension. This is showing extension or compression.
force equals spring constant times extension.
Yes, exactly. Constant times extension, yeah, or compression. So, yeah,
Force equals spring constant times extension. So extends by 5, 1.5 centimeters, or is it,
yes, 1.5 centimeter. If you subtract them, yeah,
so extension is 1.5 centimeters, but you turn that into meters.
yes, convert it into meters.
So there's 1.5 divided by 100.
Yes,
So 0.015 meters.
yes,
So an extension equals 0.15 meters. Spring constant, um, 6 newtons.
no,
Or
you have to
oh no,
find the
oh
spring
no, no.
constant.
So spring constant equals force divided by extension.
Yes, very good.
So
Forces,
force is 6
yes,
newtons. So 6 divided by 0.015
absolutely
equals
correct.
400 newton meters.
Very good. Yeah, 400 Newton
State
meters.
one property of the spring that makes it suitable for its use in the balance. Um,
Yes,
mm, uh,
because of its elasticity, right? If you stretch it, it will return to its original shape after the force is removed.
yep.
Yeah, that's why. Because it deform elasticity, it can come back to its original shape after removing the force.
Okay. Galaxies contain billions of stars. Compare the formation and life cycles of stars with a similar mass to the Sun to stars with a much greater mass than the Sun.
Yeah. So let's see this one. Uh, so we have to compare the formation and life cycles of star with a similar mass to the sun to stars, with a much greater mass than the. So similarities are, I write here similarities. All star begin in a cloud of gas and dust, okay, which is called nebula. So
Begin in a what?
begin in a cloud of gas.
A nebula.
Hmm. And then gravity pulls the gas and dust together to form a, a protostar.
Just to create
A,
protostar.
yeah. And the core heats up until nuclear fusion of hydrogen into helium.
Until nuclear fusion of hydrogen into helium.
Yes. And then star enters the stable main sequence.
Star enters stable main sequence.
Yes. So this is the formation similarities. Then it says life cycle of star with similar mass to the sun to stars. So similar mass. Then here first point is red giant. Hydrogen runs out, the star expands and then cool.
So red giant, star expands, and
And cool.
cold
Cool. Yeah.
cools.
Planetary nebula is outer layer of dust and gas. They are ejected as the star become unstable.
Outer layer of what?
Dust and gases are ejected as the star become unstable.
Yep.
And then the next one is white dwarf. A hot dense solid core is left behind, which is called white dwarf.
Hot, dense, white,
Solid
solid form,
solid core is left. After
core
that, black dwarf. When the white dwarf cools down completely and it stops emitting light.
stops emitting. Yeah, right.
Done? Okay, great. After this, what you need to do is for life cycle of massive stars which are much greater in mass than sun. So first step here is red supergiant. Red supergiant means star expand into a much larger giant when hydrogen runs out. Did you write red supergiant?
Yeah.
Next is supernova. Stars. run out of elements to collapse and explode.
Yeah.
Next is black hole remaining dense core forms a n- neutron star or a black forms a black hole if mass is extremely high.
Yeah.
Yeah, that's it.
Points in Figure 11 represent galaxies that are moving away from the Milky Way. Each arrow represents the velocity of the galaxy relative to the Milky Way. Light from all galaxies represented in Figure 11 is redshifted. What is meant by redshift?
So, what is meant by redshift?
Uh,
Redshift occurs when wavelength of light from an object increases and it shifts it toward the red end of electromagnetic spectrum.
wavelength of light increases
Yes,
and
shift it towards the red end of electromagnetic spectrum.
red end of electromagnetic system.
This happens because source of light is moving away from observer.
Yeah.
Hmm.
Explain how Figure 11 provides evidence of the Big Bang Theory.
Yeah.
Oh, that the universe is forever and ever expanding.
Yes, because arrows are showing that galaxies in all directions are moving away from the Milky Way, which is explaining the expanding of universe, right?
Yeah,
Hmm.
yeah.
Yeah, that's it.
Sometimes scientists have to change theories about the universe because new information is found.
Yeah, there are new observation evidence that does not fit into the current theory. That's why they change it.
National Grid uses transformers to change potential difference. Identify the parts of the transformer labeled in Figure 12. The C and iron core.
Yes, it is iron core.
And then A is a wire.
A is
Was the
primary coil.
primary coil and secondary coil was B.
Yes, B is secondary coil towards output.
Then there's an alternating input potential difference of 230 volts. Determine the output potential difference using physics equation sheet. Um, output potential difference. Uh, is it potential difference across primary coil divided by potential difference across secondary coil?
Yeah,
equals number of turns in primary coil divided by number of turns in secondary coil.
absolutely correct. Yeah, this one.
So potential mm, potential difference across primary coil is
Hmm.
230.
Yes,
One sec.
230. Yeah.
Turn. So primary. So potential difference primary coil was 230 divided
Yes.
by potential difference secondary, which you don't,
That's, yeah, we need to find that.
equals number of turns, which is number of turns for primary coil is 200
Yes, 200.
divided by number of turns secondary coil is 1200.
Yes.
So 200 divided by 1200.
Hmm.
200 divided by 1200 is 0.166.
Okay. 0.166. Yeah, that's correct. Let me write here.
So 230, you do 230 times 0.166.
No, because
Or,
Vs is in the denominator,
or is it
right?
divided?
Yeah, because you are going to move, this is very important, see carefully. When this variable is in the denominator, you need to bring it in the numerator. So if you bring it here, this is in multiplication with Vs, so this will go down, right? So it will
Yeah.
be like this, 230. This will move down because this is here in, um, it become opposite. It is up, it'll go down. 0.166 and this Vs goes here.
So 0.166 divided by 0.166 equals 1385.5 as the output, but
Uh,
it can't be decimal, so it has to be 1386.
yes, 1386. Yeah, okay, good.
So the answer.
Yeah, that is the answer in bold.
The input potential difference causes
So let's do one thing. I have another class now. We'll
okay.
start